Hello, good afternoon, everybody, and thank you very much for attending this webinar. The topic today will be smart water best experiences to ensure savings and quality compliance. My name is Sancho, and I'm a Senior Key Account Manager for Water, Agriculture, and Environment worldwide. Also, this webinar is a bit of special. We'll be performing the session with a partner based in Madrid. His name is Asier González, and he belongs to the company A-CING. He'll be speaking during the second part of the webinar. Before starting, I just wanted to give you some quick highlights or tips. The session and the presentation will be uploaded within the next couple of days to the website. So in case you need to log out or in the middle of the presentation, it will be available. Also, this presentation is expected to be approximately 30 minutes long. During the session, there'll be a couple of associates answering quick questions like questions or comments to links, technical guides, sections from the website, contact information. The remaining questions will be answered by Asier or myself after the presentation. So if you have any questions, if you have any comments, to Asier, please add at the end hashtag Asier if it's for him, or add hashtag Ana at the end of your question of comment if it's for me or related to my part of the presentation. Also, the session and the answers to the questions will be in English. So I appreciate if all the questions and comments are also in English. Thank you very much, and let's start. So what's the current situation of water worldwide? I just want to give you some quick data or facts about water on Earth, no? There are more than 326 million trillion gallons of water on Earth. Less than that, well, 3% approximately is fresh water, and 2/3 is located in ice or glaciers. Related to the impact of climate change or water resources. Well, as you already know, climate change is a phenomenon that we can no longer deny as its effect has become increasingly evident. And as the Earth's temperature continues to rise, glacier ice melts and impacts on the amount of fresh water that we currently have. The fact is that more than 50% of world's water comes from mountain runoff and snowmelt. And third fact, the demand of the resources grows as fast as the population in urban areas. According to a Technovavia report, water demand is likely to grow 35% over the next 5 years, and the majority comes from developing countries. On the other side, according to the UNDP, it is predicted that by 2025, most countries in Africa and West Asia will face severe water scarcity due to the increase of population and the increase of water demand. So what do we see as the main issues of the water sector? What do we see as happening right now when we try to solve an IoT project? Market fragmentation. This is a reality to manage at any point of the whole value chain, not only in geographic areas, but also in business development opportunities. So what municipalities demand and private companies demand is different, no? Some are concerned about IT and cybersecurity, some about new smart utilities, the others about their budget. Others seem to relate smart water to a smart city project. Basically, demands and necessities are not aligned. Low budget to invest in new technologies. Cost and customers' expectations seen as great unifiers, no? And then public authorities, well, the cost to renew an old system with new technologies. Scalability. Most of the companies we treat with see it as, if we invest in this technology as a POC or proof of concept, how replicable will be in a long term. Or the fear of implementing new technologies and then trying to know about if it's capable of communicating with the old ones, connecting with the old ones, and so on. And then different technologies for different applications, not a standard one. Yes, how many systems we will need to manage at the same time. So there's new technologies with their own cloud, with their own system. And then if we gather that data and we store it, we will need to store it in a separate database, in the same cloud. How efficient is having the data then? And last, a lack of knowledge to implement new technologies. Yes, there's a huge hype about technological companies, the new systems coming out, emerging on a daily basis. For instance, now everybody's talking about narrowband, and it seems that narrowband is the winning technology, no? But at the same time, there's a lack of education about smart water technologies. And also there's a lack of or need for more R&D departments within companies. How IoT can help solve problems and save water. A standard platform to capture the data coming from any sensor, any protocol, any device. In the water sector, for water, the intelligence and the power of standardization will be in the IoT cloud platforms, which will be developed or will need to develop to standardize the information coming from any protocol, any sensor, from the old SCADAs, from all devices, to receive real-time data from remote areas. Well, some years ago, it was impossible to think about having real-time data from important parameters, from rivers, lakes, environment, but nowadays it's a reality. IoT can make this happen. To prevent versus to fix. And here, I would like to bring an example. Water resources and water quality are very related to oil exploration. And in any oil operation, there's a risk for water resources and also for any kind of life living in that kind of habitat. However, having real-time data continuously allows us to act in a very early stage of a natural disaster. And lastly, to be cost-effective, no? To save money and resources and act consequently, to be able to justify the return of the investment, to be able to allow to stop a valve if it leaks, to monitor water consumption in real time, or to detect pollution in an early stage, to monitor fish farms, and to justify traceability, and to produce more with healthier conditions. And what does Libelium have to offer in the water sector? Well, I'm not going to go into details of what we do as a company, as Libelium. There's other webinars that talk about what do we do as a company, but just to kindly remind you that we design and manufacture hardware for IoT solutions to provide wireless sensor networks. And one of our main features is the interoperability. Our platform allows or solves the market fragmentation. It's modular, is horizontal, and with an ecosystem of more than 80 partners and distributors, helps engineering companies and international corporations to solve problems in the water sector. And what do we offer as a solution for the water sector? We basically offer a solution for water monitoring. That does not mean, and you'll see when Asier presents his part of the of the solutions and projects that we cannot, or we are not capable of approaching any other project in the other IoT sector. But right now in our portfolio, we offer mostly water quality, 4 basic parameters like pH, dissolved oxygen, conductivity, but also we have specialized sensors for ion concentration in water. Also, we can go from applications to monitoring drinking water, quality fish farms, water treatments, even for precision agriculture. As an example, I just want to introduce just a few applications. I'm not going to go into deep on the case studies. You can always look up that information in libelium.com/case studies. And Asier also will give you more information about, more detailed information about different case studies. But just to give you an idea of what you can do within IoT, the first one is monitoring fish farms. This particular case study is in Vietnam, but I mean, it could be replicable worldwide. The aim of this project was to monitor real-time different parameters in real time to control water quality and to prevent diseases that could affect fish or to improve the quality and the quantity. Basically, this is mostly done or do because to meet international regulations. Now, there's a lot of exportation from Vietnam or Asia to Europe, and quality control regulations and traceability to ensure health within fish farms was required. There's a couple of pictures of the deployment, but basically to be aware, to prevent diseases in order to save cost, no? The next one is a project developed in Spain, but it's environmental impact detection system. And the idea was to reduce environmental impact generated by building, industry, or construction activity. By installing different sensors like water quality monitoring sensors or air quality monitoring sensors, they were able to reduce the measurement time and the impact monitoring. Also, they were able to respond on time in any kind of alarm situation. To minimize the harm, also stops just in case something is happening. A last case study, we released this around August, I believe. I wanted to present it just because I think it's something very unique and special. It was done by one of my associates or partners in United States, in West Virginia. We was preserving endangered freshwater mussels. It's a little bit in between environmental impact and fish farms. But basically, the Ohio River is the home of population of a lot of different species of mussels, and it's a high quality indicator, or a high indicator for water quality. This system, well, the unique thing of this system is that they integrated our sensors and also third-party sensors in a buoy in order to provide real-time data transmission that could affect mussels. The main goal of the project has been to monitor and minimize the effects of dredging activities on local mussel populations. Right now, at the moment, and you'll see that Asier will present other case studies or different applications with OEM and third-party sensors. And now, Asier, it's your turn.
Okay, thanks, Anna. Hello, everybody. My name is Asier, and thanks to Libelium, and thank you for attending this webinar too, okay? Firstly, I'm going to introduce my company, A-CING. We are a consultancy and engineering company focused on ICT, water, and environmental technologies, with presence in Spain and Mexico. Okay, we are part of the multinational group TPF with more than 4,500 employees in 65 countries and with experience in more than 80 countries. Okay. Related to this webinar, we offer broad water services and solutions portfolio about I don't know, water supply and wastewater distribution systems, leakage detection, water management optimization, and smart waters projects in general. Okay, for municipalities, industry, large consumers, and smart cities. Okay. You can get more information about A-CING in our website. Okay, if I focus in smart water projects, we work mainly as integrators in every layer of IoT. Okay. In the lower layer, we select the proper sensors and electronic devices in order to meet our customers' requirements. And as probably you already know, for many of IoT projects, one of the most important features is the power consumption of electronic devices and sensors. Sometimes I think that it's critical for the viability of the project. Okay. Regarding to the communication layer, the communication systems, we have worked with all technologies you can see in the slide. And we are now testing new ones too. We choose always one of them according to the range of the technology, the battery consumption, one more time, and the number of bytes to transmit. Okay, it's the information to transmit for not technological people. Okay, all of them are very important, and besides and obviously, we have to take into account the country regulations too. Okay. Once we have done the measure, we send all collected data, to a platform for being processed and analyzed. Okay. As Anna has told you before, okay, I want to stop here to emphasize the value of data, okay, because it's really, really important for our business, and not so much how we get it, but what is the information we get, okay? Especially for final customers who sometimes are more worried about what kind of technology they need to use than how to use data for improving their business. Okay? Sometimes in this platform layer, we have developed customized software, but my experience tell me that in IoT projects there is no word, okay, in developing software in-house, because platforms have been designed and developed for covering all IoT needs. Okay, so don't waste your money, I think. Okay. If you want, I can tell you later the features we look for in a platform, but I'm going to follow with the next slides. Okay. Finally, we have the last layer, the visualization layer, which need to be accessible from any place and any device. Regarding to Libelium technology, we work with both lines, okay, the plug and sense and the OEM lines. But firstly, I want to explain you why Libelium, okay? So, well, the main reason we use Libelium technology is because we can reduce very much the time to market. And we can modify the products in a short period of time. And we consider that in IoT business model, it's very important to reach the market quickly. In my opinion, wash mode is a good electronic device, and only in those cases where we need integrate new sensors, or sometimes we need sensors with more accuracy. So in those cases, we use the OEM line, okay? Okay, so I'm going to talk you a little more about OEM products before explaining some case studies, okay? From my point of view, the benefits of using this line are that we can integrate our own sensors, okay? Because as I have told you, sometimes we need more reliable sensors and with more accuracy, although it's true that in that times, sometimes they are too expensive, okay? And other times simply it's because the sensors we need, they are not in Libelium's portfolio, okay? The OEM line allow us to integrate more communication modules, a part of certificated ones, add our powering systems, reduce cost, and be more competitive, okay? And it's the same, and reduce the time to market, okay? But all is not well when you decide to use OEM line. So you have to take into account some issues, okay? Because you have to assign money, you have to spend time and human resources for testing the new configurations, for procurement of materials, assembly the devices, and obviously the certifications, okay, the CE marking and so on. So please, if you are thinking in using OEM line, take this into account, okay? Finally, I'm going to explain you some case studies. We have selected the more important for us and water-related case studies, okay? The first one is an Horizon 2020 project, water efficiency and safety in living areas. The goal of this project was developing a real-time system to detect water usage patterns, anomalies, and predictive alerts for user and operators. We needed to open and close valves in some cases, okay? For it, Libelium technology for reading an ultrasonic flow meter, the Sophia DOS platform for getting, processing, and analyzing that data, and an own web application for the final customer. In this case, owing to have to read and send too much information, we needed to plug the device to the power line and to use 3G communications. The second one is about consumption and efficiency in big water consumers. For instance, in this case, we connected some water pulse meters to one wash mode with Sigfox technology in order to control the water consumption in a big consumer. I will show you later, but only with this kind of controls and with leakage detections, for example, you can reduce the consumption up to 40%, I think. Okay. Another case study is this one where we are monitoring some critical parameters in waste water treatment process. The smart water solution for wastewater treatment, this is being tested and validated in four different worldwide locations: in Spain, Denmark, Argentina, and Mexico. The main requirements for the project are reading parameters every 15 minutes, sending information to the cloud platform. In this case is IDBox, a Spanish company. Extracting data, patterns, alerts, and predictions, and visualize all collected and predicted data. In this way, we can monitor wetland behavior in real time. It's important that all of these devices are installed in isolated locations, okay, without power supply. So one more time here, the power supply and the power consumption is very, very important in the design, okay. And in this case, as there are about, I think, about 25 sensors, we use a mesh network for reading data, okay. Then in Libelium, we send data to IDBox with 3G technology, okay. And I'm going to explain the last two case studies. This one is about basins monitoring, the quality in rivers, where we are monitoring not only water quality parameters, but some PLCs and SCADAs for monitoring water infrastructures in real time. In this case, we use Sigfox technology for wireless devices, and again, IDBox platform for process and analyze all data. Okay. And the last one is the efficiency in buildings. It's very similar to the case study based in big consumers, but in this case we are monitoring not only the water consumption but gas and electricity. Okay. In the last slide, in this case, as I have told you, as many people ask us about the results, in the last slide, you can see the evolution of water consumption in one of our customers for the last 5 years, okay? And you can see how they have reduced the consumption up to 50% from 2012 to 2016, okay? Okay, now it's time to Anna to ask some of your questions. Later will be my turn. So please, Anna, go on, okay?
Thank you very much, Asier. Let's start with our first question. This comes from Ruti Verma. How many sensors are we talking about in a typical engagement? Well, depending a little bit on the proof of concept. We were waiting for Asier to answer some questions. I don't know if he's having any technical problems. Andrea, can you pass me some of the questions for Asier? I'll try to answer them. Basically, for a proof of concept, you can go with 1 or 2 devices, but there's, depending on the project, no? Sometimes for just to monitor one point, like in one of our case studies, there's a need to choose 1, maybe 2 for replacement. Some of them to monitor like continuously in different parts of the river, you might need 10, 20 devices. We can go from projects of 80 units or projects of 2, 5 units, depending a little bit on the type of project, and the needs of the customer. Next question. Is there any next question? Yes. I guess there's no more questions. Is there any more questions? Lara with, what communication protocol do these sensors connect to? Well, we have a wide range of communication protocols. I show that on a slide 5th or 6th. I mean, depending on the type of project, we choose or recommend one type of communication protocol or another. As Asier also mentioned, like sometimes, depending on the amount of data needed, just for instance, 1 second, if you need to generate data every second, then you might need 4G, GPRS, cellular connectivity to meet the customer's expectations. If you need to connect data or send data every 15 minutes, 10 minutes, and there's no cellular connectivity and you need like a wide range of radio protocol, then we might go with LoRaWAN or 900 HP or 868. But if we have Wi-Fi connectivity and this project is deployed on a city, then we might recommend Wi-Fi. So we try to adapt the protocol depending on the project, depending on the IoT project, depending on the customer's needs, and also depending on the geographical area. Next question. Are you pleased with LoRa and Sigfox network? Well, even I would say yes, but you need to know, or you need to consider that there are different types of connectivity options, no? When we talk about Sigfox, Sigfox relies on a network and connectivity. You cannot deploy your own private network. You always need to hire a service. So if you do not have Sigfox connectivity or the network is not developed enough, you might not be able to implement Sigfox. Plus, Sigfox has a limitation. It's very reliable though, but has a limitation of 44 bytes. Sorry, 12 bytes per message, 144 bytes per day. LoRaWAN, you need to rely on a backend. However, you have less limitations when sending amount of data, and then you can either hire the service if your network provider has LoRaWAN connectivity, or you can either build your own private LoRaWAN network. However, you still need to pay for base station, and you still need to pay for that back end, where Sigfox is much more simple. Next question, is it possible to see an online demo? Well, unfortunately not today. We are on streaming, and it's kind of complicated. We did this presentation within 2 cities right now, and we've been working on this the whole day. City is based in Madrid, and we are based in Zaragoza, so it was kind of a challenge. I hope you guys liked it. Maybe next time, or if, I don't know who asked this question about the demo, but please feel free to contact us directly, either myself, here. You can either write to us directly at, well, that's my email address, or you can either write to Asier directly if you guys have any additional questions, or if you want a demo, online demo. Next question, what are the main advantages or disadvantages between LoRaWAN? I answered that one correctly already, right? Okay. Next question. If you charge the batteries with a PC or renewable sources, what is the credibility of batteries in the long term? Okay, usually within a week. However, keep in mind on the amount of data you're sending and how often you send in the data. Different protocols have different consumption, and also every time you send a stream of data, Wasmol falls asleep to save energy. But if you're sending data every 2 seconds, like in this project for water consumption, then obviously you need to be able to connect to a direct source of energy, because Wasmol is constantly awake sending data. So sending data every 15 minutes with let's say 6 sensors in a radio protocol or cellular, you should be able to get a lifetime battery of a week. Next question, I think this will be the last one for me, and then we change into Asier. Andre from Portugal. In any of the examples provided, do you integrate with other IoT platforms, both as a source of data or as a client system consuming Libelium data? Okay, so I'm not sure if I'm understanding this question correctly, so I'm going to answer it the best I can. But Andre from Portugal, if I do not answer your question, please feel free to send me an email. I will be very happy to answer your question. Okay, so we work with other platforms. Asier just provided some examples of IoT platforms who you can work with in the water sector, but we have integrated more than 43 different clouds. So any of our customers can work, if they want, with any of our cloud partner providers. That doesn't mean that you need to use them. You can either create your own platform, create your own application, or visualize the raw data if you want to just visualize the raw data. We do not, client system consuming, we do not work with direct customers or end users. It's always direct system integrators or engineering companies. Our business model is business to business. So once we generate the data and the customer gathers that data, whatever the customer does with the data, we do not have any control on that anymore, and there's no fee involved on paying. I don't know if I'm answering this question correctly, but I don't know, there's no extra fee involved within the data. So the customer can create a module, analyze the data, do a predictive module, or give a service to the end user. And now we're passing the microphone to Asier. Well, actually, I'm connecting to Asier in Madrid, and he'll be able to give you answers to the rest of the questions. If there's any additional question for myself or Anna, feel free to send me an email, or to contact Andrea, who is managing the chat. Asier?
Hi, thanks, Anna. Sorry for the last problems. So I'm going to try to resolve the questions. Okay. The first one is, does your typical solution include a GIS to locate and visualize sensors along a river or a fish farm? Okay, in a river, our clients, our customers, they don't usually ask for a GIS system, okay? But it's true that in water management system and in water distribution networks, we use GIS systems to visualize sensors and different elements in the network. So if you need if one of our customers in a river need it, we can use it, okay, with no problem, okay, because always the platforms that we use, all of them they support this kind of technologies. The second one is what are the parameters being measured for wastewater? Okay. In typical projects for wastewater, we usually have to read water parameters and environmental parameters. Okay. In water, we usually read the conductivity, the dissolved oxygen, pH, and oxidation reduction potential. Okay. Besides the temperature and some specific sensors that some treatment plants they use for read and extra parameters that I can't tell you for confidential reasons. Okay. Regarding to environmental parameters, we usually read to the solar radiation, luminosity, pluviometer, and all of these kind of parameters. Sometimes because these water treatment systems are natural systems, so they need to know how they are going to evolution all over the time. Okay. Another question is, I'm looking for it, is, okay, what's the range of Wi-Fi mesh network? Okay, it depends, okay, because I don't know if you know, but the regulation in countries is very different, and the power of the radio transmitters is not the same, for example, in Europe and in America. But it's very typical that the maximum distance, it's about 100 meters or 200, okay? And besides in radio communications, it depends on some buildings or rivers or some details. Okay, when we are going to make a project, we usually do a coverage study in order to fit the best solution. Okay. And the last one is about, okay, it's about the Sigfox technology. Can you repeat the data throughput on Sigfox again? Did you say 144 bytes per day or per day per the fees. Okay. I haven't. But it's the same. I'm going to solve this question. In Sigfox technology, the most important is that you only can send 14. I think that it's 14 bytes per frame. Okay. And you can send about 140 frames per day. Okay. So you have to take into account how many sensors you have, how many times are you going to send data, and so on. Okay. Okay, that's all. If you have any question, or because we don't have much time, please feel free for sending me an email or contact me through social networks. And one more time, thank you so much for attending webinar. Okay, and let's Anna to close the session. Thanks.